So here's a little extra practice with implicit derivatives. I think sometimes it's helpful just to be able to hear the thinking again and all the things that are not written down. So suppose we had a problem like the following. Find dy dx for the relationship given by, let's say it was something like x squared y plus x equals 5. So what we would do here is go ahead and start by differentiating both sides of the equation. So we're going to start with something like this. Symbolically, remember, d dx just means take the derivative. And before we get too far, I want to start by just thinking about this first term, the x squared y. And remember that when we have a product that we want to take a derivative of, something like f times g, what we get is the first derivative of the first times the second plus the first times derivative of the second. And how we label doesn't matter for the product rule. As long as we have derivative of one term, the other term left alone, and then swap the two terms. So we're going to apply the product rule here to x squared y. So as I take the derivative, we're really just substituting x squared as my f and y is my g. And so if I look at the product rule, I have derivative of f prime first. And that would be derivative of x squared, which is just 2x. And note it's a derivative with respect to x, which is why I get a 2x. I could, in theory, think about getting a dx, but that would just produce a 1. And then multiplied by, leave the y alone, which is my g. And then next, I will leave the x squared alone, and then take the derivative of y, but that just gives me a dy dx. And then I move to the second term. The x term by itself, derivative of x with respect to x is 1. And then on the right, derivative of a constant, the 5, is 0. The next step in all of the related rates is to solve for dy dx. Ultimately, that's what I was asked to find. So I will take and try and rearrange this to get dy dx. Primarily just need to get this term by itself and everything else on the other side. So in order to do that, I will just subtract it all to the other side. So I have x squared dy dx equals, moving the 1 over, it becomes a minus 1 on the other side, and moving the 2xy to the other side, I get a minus 2xy. And lastly, I just need to divide by the x squared, divide both sides by it. So I will do that and get dy dx equals minus 1 minus 2xy all over x squared. Now some of the questions will ask you to find the slope of the tangent at a particular point. If that were the question, we know the slope of the tangent is the derivative, so that's the same as asking for dy dx, and if it's at a particular point, we would just plug that in to this final equation to get a single number. But the hard work's in finding dy dx. So I hope you find this helpful, and I look forward to seeing you in class.